Welcome back, guys. So today we will continue population growth. So today we will be learning about exponential growth model. So exponential growth occurs in any situation where the increase in some quantity is proportional to the amount currently present. So what I mean by is that, so it will look something like this. So this is what it looks like. So now I'll just derive the expression. So this is for most events of interest in environment. It is usually assumed that the growth curve is smooth and a continuous function. One way to state the condition is the exponential growth. So we'll study this. And the rate of change of the quantity n is proportional to the n. That is here what I explained this. So now I'll just remove the proportionality sign. So here R is the rate of growth or average growth rate constant. Now integrating on both sides. So this will look something like this. So now we just integrate it. So the integration of this will be ln nt, and this will be rt plus a constant c. So we'll find the values. So at t equals to 0 and t equals to, suppose, n naught, that is initial, and so then we'll find, if you put here 0, then c will be c or z, something, take an integration constant. This is ln and 0. So now we'll just put these values. So ln nt, that is equals to rt plus ln n0. So writing this will look something like this. So nt by n0, that is equals to e to the power rt, nt equals to n naught e to the power rt. So this is our exponential growth rate model, and if you plot the graph, it will be something like this. So this is the time nt, and if you put the value of t equals to 0, e to the power 0 is 1, and the nt will start from a certain point, that is n0, and it will go exponentially. So this is n0. This was exponential growth model. So I will explain you with an example. I will show you example. So I'm reading the question, something like that. So United States in 1986 US produced 2.4 into 10 to the power 12 kilowatt hour of electricity, and the average annual growth rate of US demand in 15 years after 1973 oil embargo was about 2.2%. Estimate the electric consumption in 2086 in the 2.2% per year growth rate remains constant. So now we'll just solve this. So n100 equals to, that is 1986 minus 2086 minus 1986, that will give 100. So n100 equals to n0, that is initial, 1 plus r 100. So this is also formula which I haven't told, but let me write that also. So for exponential growth, nt equals to n naught 1 plus r to the power t. So this is also an exponential formula. So if you expand this by binomial expansion, it will be this like this. So it is also from formula. So you will apply this. So t was 100 and r, that is 2.22%. So n naught is 2.4 in 10 to the power 12, and this is 1 plus 0.022 100. So this will be calculated, and this will be the final answer. So thanks for watching it. So if you have any problems, comment below. If you like the video, subscribe to my channel.